Trial and improvement is something that we use to try and solve harder equations than just linear equations. Most equations don't have integer or whole number solutions. So what we need to do sometimes is use this method, which is loosely based around guesswork. So you make an intelligent guess and substitute your value into the equation. And then depending on what the answer works out to be, you make a better guess. So this is a very practical approach to solving equations, and the applications to this are applied in lots of different places. Just that method of trying something and then improving on it. So inventors, engineers, lots of different places make something new, they see how it works, and then they try a better version of it, they try and modify it, and they keep going until they've got the best possible product. And it's the same idea with these equations. So what we do, we make an intelligent guess until we've got two consecutive integers or whole numbers that straddle the target number. Then we go to one decimal place and we try and get two consecutive one decimal numbers that straddle the target number, and then we go halfway between those two to decide which is the correct solution. This is a really intuitive process, and it's one that we shouldn't struggle with. So if we're trying to solve x squared minus x equals 27, what we need to do is try and pick out some x values that we're going to use, and we're going to substitute those into x squared minus x, and we want the target to be 27. So we want all the answers to be as close as 27, and we'll see if they're too big or too small. And if they're too big, then we'll make our x value smaller. If they're too small, then we'll make our x value bigger. So what we could try here is try x equals 2. And whenever we put that into x squared minus 2x, we get 2 squared minus 2, which is 4 minus 2, which is 2, which is clearly too small. So we could try x equals 3, and we'd have 3 squared minus 3, which is 9 minus 3 is 6. Again, that's too small. 4 squared minus 4 is going to be 16 minus 4, which is 12. So that's too small. 5 squared minus 5, which is 20, which is too small, but we're getting closer. And then 6 squared minus 6 is 36, take away 6, which is 30, which is too big. So what we now know is that our answer lies between 5 and 6, because those values straddle our target number of 27. So then what we do is we go to one decimal place. So one decimal place is going to be 5.5. And if we do 5.5 squared minus 5.5, we get 24.75, which is too small. 5.6, so that's 5.6 squared minus 5.6, and we get 25.76, which again is too small. 5.7, so that's 5.7 squared minus 5.7, which is 26.79, so it's close, but again it's too small. So then 5.8, which is 5.8 squared minus 5.8, which is 27.84, which is too big. So again then we've got two numbers that straddle our target number of 27. So now we go halfway between those two numbers. So we're going to have 5.75. So 5.75 squared minus 5.75 is 27.3125, which again is too big. So because our halfway value is too big, that means the answer of 27 is going to come from a value of 5.7. That's the closest that we can get to one decimal place. So our answer there is x equals 5.7. Our next example then, solve x cubed plus 2x equals 6. So if we draw our table first of all, So we're going to think about our x values, x cubed plus 2x, and we want the target number to be 6, and then it's going to be too big or too small. So let's try x equals 1. We're going to have 1 cubed plus 2 times 1, which is 3, which is too small. So then 2 cubed plus 2 times 2, so that's 8 plus 4, which is 12, which is too big. So what we've got then is two numbers that are straddling either side of our target number of 6. So then we need to go halfway and try and get to 1 decimal place. So 1.5 is going to be 1.5 cubed plus 2 times 1.5, which is, so that's 6.375, so that's too big. Try 1.4, and with 1.4 cubed plus 2 times 1.4, which is 5.544, which is too small. So again, we're now straddling our target number of 6. And it would look like 1.5 is closer, but we need to do a check to 2 decimal places. So if we look at 1.45, so halfway between the 1.4 and 1.5, it's going to be 1.45 cubed plus 2 times 1.45, which is 5.9486, which again is too small. So therefore the halfway point is too small, so the answer is going to be 1.5.